Welcome everyone to day 2 of the first IntraFish Aquaculture Innovation Summit. I'm Drew Cherry, Editor-in-Chief. So part of the challenge for aquaculture production, the seafood demand is going to continue to grow according to pretty much all projections from the FAO on. But there is a shortage of space and what we can do on land. There's a shortage of potential for growth inshore. So moving offshore is one of the potential solutions for how we're going to grow all this fish that is needed. There's a lot of technical hurdles to overcome. It is quite different from the standard finfish that's being raised in near shore. And there have been some executives that have been working on this for a long time, ironing out the kinks and really taking some risks in trying to get these things launched. So we're very lucky that one of those executives is going to be opening the event and really setting the stage for us for the offshore panel, which will be moderated by my colleague Rachel Mutter after this next presentation. So I want to introduce Langley Gace. He's the Senior VP of Business Development at Innovasea. And Langley, the floor is over to you, and I will let you go ahead and launch into your presentation when you are ready.
Thank you, Drew. Can you hear me?
Hear you just perfect. Yep.
Great. Thank you very much. And indeed, we have been working on this for a long time. A lot of familiar faces on the panel. So today, I'm going to talk about how Innovasea is changing open ocean fish farming for the better. And because time is limited, I'm going to jump right into it. To start off, let's just have a quick discussion on where we are today with open ocean aquaculture, or better yet, just a few years ago. We've had a solid track record. We've had pens and grid systems withstand multiple Category 4, some 5 Category 5 hurricanes and typhoons. We've made significant headway on operational equipment. We can stock nursery nets while the pens are submerged. We can clean the pens passively. Here in the photo you see the top half of the sea station is out, and the wind is desiccating any biofouling on the Kiko net, and below water is brass netting, which stays naturally clean. Harvesting's relatively easy. We have farms harvesting when they want to in the open ocean, bar an extreme weather event, but for the most part, they're delivering fish to market on time. So why did we go into the open ocean in the first place? Well, we believe one gets a superior product. The two things I always like to say is your fish never see or swim in the same water twice. And you have a complete water exchange about every 90 seconds to about a minute and a half, depending on your cage type and current. So a lot of advantages, but it still has its challenges. So a few years back as a company, we looked at see what was the biggest lever we could pull to improve the situation. How could we improve the bottom line? And so simply put, we looked at the numbers, and it was increasing the efficiency in feeding. So let's look at the numbers. So feeding accounts for about half of the farm's OPEX budget. So a small tweak in the positive direction of the economic FCR can have dramatic effects on reducing the cost of operations. In fact, reducing the FCR by 10% on a farm with a few thousand tons of fish can yield a cost reduction of over $1 million. And note that I did say EFCR. It's not just how fast and efficiently the fish are growing. It's about not overfeeding, not feeding in conditions that won't support efficient feeding. Say, for instance, a strong current when the pellets are escaping from the fish, escaping from the pen. And you don't want to feed when the fish are stressed, because you're simply just throwing feed into the ocean. And that could be, say, a predator's nearby or extreme temps or low DO. So it's about bringing more fish to market. So less loss to predation, storm damage, more improved feeding. So to us, it's really dollars or euros in versus dollars or euros out, not just kilograms in, kilograms out. So we'll start with underwater or submerged feeding. And so what that means to us is the pens are submerged, the feeder is topside. And why do we feed to submerged pens? Well, first of all, the fish are less stressed in the calms of the depth. There are other benefits to submerged feeding if you have surface-based parasites, algae blooms, or temperature conditions, below or above. We've got clients in the Atlantic and the Pacific and Asia that play the thermocline. So the feed is delivered in a water slurry as opposed to air. And for the engineers in the audience, that's in a nice, slow laminar flow, which prohibits less pellet collisions, which lead to pellet damage or fines, the dust that you have. So we've actually got it down to about less than 1% pellet damage when we deliver pellets to the cage. Again, that's helping drive down the economic FCR. Real quick before I leave this slide, here is a drawing of our modular feeder. So all the equipments, the silos, the pumps, come on skids or pallets. And that allows for a couple of things. One, it allows you to build up your silos as your business grows. And then secondly, if you have a problem with the pump, you can easily switch it out and replace it with another one in about an hour and a half. So you're not having downtime with feeding. So you're not missing those feeding opportunities. So in closing, it's preserving capital for when it's needed and also reducing downtime. So if we're going to farm submerged, we need to see what we're doing. So our company has developed these digital IP submersible cameras, all coupled to a submersible network. So what that means, that network is transmitting data to a single location on site and then either back to shore or to a vessel on site. Just to give you a perspective of the size of those cameras, it's about the size of a can of Coke. The IP stands for Internet Protocol, and it allows us to collect digital video as opposed to analog video. And so digital data from multiple cameras, not just a single camera, but digital data from multiple cameras can be transmitted on a single fiber optic cable. So this significantly reduces the amount of cables coming to a central point, whether it's a communications buoy or a vessel. Our system is capable of up to 6 cameras per pen, and as many as you want on the grid. The 6 cameras is limited by a switch at the pen. And when transmitting the video data to shore, say to the feed manager's office in a comfortable air-conditioned or heated office on shore, the bandwidth allows for up to 8 cameras in real time. When you're viewing, say on site, say on the barge, there are really no limits. You can look at as many cameras as you want. And then finally, we use our proprietary UV light excitation technology. It's a flashing UV light that keeps this lens clean for about 3 to 4 months, reducing maintenance time. So now that we have all these fine images and videos, what do we do with them? So keep in mind, I am focusing on feeding during this presentation. It's about minimizing waste and optimizing feed opportunities. So we have a pretty impressive deep learning AI team in our various offices, and they've developed algorithms, and one of them is to detect fish satiation. So to sense when the fish are done feeding. So the algorithm determines based on known behavioral swimming patterns unique to that species whether the fish are still hungry or they're becoming satiated. And the software that the user looks at displays a satiation index. So it's quantified. Again, it's not to take the place of the feed manager. It's just to assist them in deciding whether to adjust the feed rate or to stop the feeding. Pellet detection is another tool we use to determine whether we're overfeeding or underfeeding. Feed managers, again, look at this. You'll see the blue dots there. That's detecting fish pellets. And again, it sends alerts to a feed manager to slow down or potentially stop the feeding. Knowing how much biomass you have is probably one of the most important parameters in aquaculture. This allows you to determine how much feed to deliver each day, track your growth rate, see if anything's going wrong, and also to either predict targeted harvest dates or how much you will be able to harvest on a certain date. So again, our AI team has developed a biomass estimation tool that samples a statistically significant number of fish, and we're able right now to produce less than a 3% error of the biomass in the pen in near real time. So how do we do this? Well, we have a camera, a stereoscopic camera. It has 2 lenses. It's roughly 30 centimeters long by about 15 centimeters in diameter, so a foot long by 6 inches in diameter. It's installed in the pen, it's battery operated, lasts for about 8 hours, and it uses depth perception to collect dimensional biometrics. And the algorithms then calculate the weight based on those measurements, based on specific growth curves. So the camera is retrieved, the data can be downloaded through Bluetooth or cable to a laptop right on site, and it can be analyzed there or anywhere in the cloud once you connect that laptop to the internet. We do have to train those algorithms. If it's a new species, it typically takes about 5 to 8 months. Currently, we have algorithms for cobia, snapper, salmon, seriola, and we've got a few more in the pipeline. So, environmental monitoring. So this is the final set of critical data for efficient feeding, understanding what's happening at the site. So to do this, we use our AquaMeasure sensor, and it's that black unit that's attached to the side of the spar about halfway down. It's about the size of a handheld flashlight or torch, and it uses just a D-size battery, which lasts about a year. And it collects a host of environmental data, the typical ones: DO, salinity, temperature, depth, turbidity, pH, and so forth. And it transmits this data acoustically or wirelessly to a submerged hub up to 500 meters away below a surface buoy. That hub is then connected by wire to the surface buoy, and then that data is then transmitted wirelessly to shore or to a vessel on site. So all of this leads to what we call remote multifactor feeding. So the feed operator sits in front of a control center with easy-to-read display panels. And typically what you see is maybe the farm location, weather, and ocean conditions. Is the current too strong to feed? How much biomass you have on site in the pen, the status of the feed and the feed equipment, how much each pen has been fed either that day or in aggregate. Are the fish stressed? So it looks at a combination of parameters to determine if the fish are stressed and maybe it's not a good time to feed or slow down the feed. So in closing, all what he or she sees stems or comes from that high-resolution data from the IP cameras, the pellet detection, the fish satiation algorithms, the biomass camera and those algorithms, the environmental sensors, the weather stations, all aid the feed manager in their goal for more efficient feeding. So this, coupled with submerged feeding with less fine loss, less than 1%, leads to a lower economic FCR and a better bottom line. So couple of 5 closing points I want to leave you with, and we'll just go through them quickly and then we'll head to the panel. So first of all, during storms, fish prefer to swim to deeper depths. Excuse me. Equipment will last longer if it doesn't see those high-frequency fatigue cycles just back and forth of the daily chop. And if we're to farm in the open ocean, we must move as much of the operation below to the calm waters and the actual habitat of the fish. Number 2, efficient feeding is critical to a successful farm operation. Approaching this challenge from many directions, it's multifactor, multifaceted. In aggregate, all these small improvements will lead to a better FCR. Number 3, operating your farm from a central location. This will see increased efficiency as well as safety. Feeding from a central location means less vessel maneuvering, less opportunity for mistakes and injury. And then controlling feed operations from a central location will reduce costs and improve efficiency. The feed manager is in a comfortable location. He or she has all the data right in front of them and can make the decision. Number 4, being aware of current or ongoing situations in real time is critical to managing any operation, whether it's fish farming or anything else. So understanding those ocean conditions as you prepare for the day's daily operation, whether it's feeding, maintenance, or something else, knowing what's happening offshore at your site, even though you can't see it, is critical. As well as being alerted to abnormal data, such as high or low temperatures, low DO, or even equipment status, such as, say, an anchor line tension that's not exactly reading as it should be. So this will reduce costs due to minimal fish loss and equipment damage. And finally, number 5, using analytics to process all the data collected. This certainly helps aid farm management in making timely and effective decisions, ultimately reducing costs and increasing the safety and profitability of the farm. Thanks for your time, and I look forward to joining the panel.